In lesson 97, you see up on the board, we are talking about the ambiguous case. And does anybody know that vocabulary word? Just what does the English word ambiguous mean? Julian? It's vague. We're not sure if it's this or if it's that. And where we're going to talk about that is with the law of signs. We've already talked about the law of signs automatically gives you an acute answer. But maybe your angle isn't really acute. The ones we've been doing up until now, we've been able to use some logic by biggest side is across from biggest angle and smallest angle is across from smallest side to figure out what we needed, whether it would be acute or obtuse. But that does not always work. It depends on what information they give us at the beginning of the problem. Sometimes they don't give us enough to tell, and so it could be acute or it could be obtuse. So we have to go through and solve it both ways. Get all of the values if that first angle is acute. Give all of the values if the first angle we find is obtuse. So that's what we're going to be working through today. So let me put some pictures up here of different things that might be happening as we're doing these. And for all of these, we are going to talk about triangles where they give us one angle, so we know how big that is. They tell us how big the opposite side is, so we have a number for that. And they tell us how long one of the other two sides is. So we know that side has to go from here to here, but we don't know how long that side on the bottom is. We do know how long the side that I drew on the right is. But I didn't draw it yet because I'm not sure. Maybe it needs to come straight down as a right angle. Maybe it needs to angle in like you see right here. Or maybe it needs to angle out somewhere over there. So maybe it angles in and I got an obtuse right here. Maybe it angles out and I have an acute angle right here. The other thing that might happen is we know the shortest distance from the end of this side that we know, for this one it's 9, down to here has to be a certain number long. And we also know that the shortest distance from this point up here at the top to the line down at the bottom is if we come straight down. So the shortest it could be is the same as the height of that triangle. And if they happen to tell us a number that's not long enough, maybe we have no triangle right there. It doesn't really touch and meet. The ambiguous case is going to be what you see in pictures 3 and 4. This is our ambiguous case. With the numbers that we are given, notice this and this are the same length. So if I imagine a pivot right up here at the end of the side 9 that I know, and I know this side has to be some number long, I don't know, maybe it's 7 or something. I could either swing that 7 so that it goes in and forms the obtuse angle, or I could keep that pivot and angle it out here to make that acute angle. So you see how you've got those two cases there. The other thing that may happen is that other side that I know, that side A, might just be super long. So I could angle it way out here. I know how long that 9 was. That stays fixed. I can draw this side however long I need to. So I keep this pivoted. This is super long. And so I angle it way out here until it lines up evenly and I have that acute angle. If I kept it that super long length and tried to angle it back the other way to get that obtuse angle down there, so let's see, if I put it here, it's still way too long, it's going below the line, I've got to keep pivoting it farther. Even here, it's too long. I've got to come way out here somewhere. And then that would mean that my 3 sides are that original 9, this side that makes 40 degrees that I don't know how long it is, and then this super long one that would have to come out here. That just gives me a zigzag. That doesn't close and make a triangle. So I could not go out that way. If A is super long, I can only bend it so that it goes way out to the right to form that acute angle. So what we're going to try to do is to figure out, well, how do we know? Is it just acute? Is it just obtuse? Is it both? How do we figure this out? Is it a right angle? How can we figure out what's going on? So here are those same pictures again. And no matter which one of these I did, if I ended up with a right triangle, this would be the height of that triangle. It would happen to be the same as that opposite side. I'm not going to worry about the one that isn't a triangle because I don't know how to talk about height of one really that isn't a triangle. If I had this one where I got the obtuse angle, my height would still be that same amount like in the first picture. Or if I had this one where I pulled the side out and had the acute angle, my height would be the same. So for all of these with the 9 and the 40 degrees, that height would be the same right there. That's going to be the trick to what's going on. It's the first thing that we have to do to compare and figure these out. So no matter which one of these I pick, if I'm looking just at the right triangle part, I want to know the H, I know the 9, and I know the 40 degrees. So for the 40 degrees, H is the opposite, the 9 is the hypotenuse. That sounds to me like SOHCAHTOA for sine. So I could say that the sine of, in this case, 40 degrees, but in general, the sine of A would have to be H over 9. So that would mean H is 9 times the sine of 40. If I did it with little b instead, it would be H over b. So H would be little b sine A, which is the formula that you see right here. That's the formula we're going to need to test to see if we have an ambiguous case or not. We want to find the height of the triangle. If, picture 1, the height is the same as that opposite side, remember A is a number, they tell us a number in there. If the height is the same as the number for that opposite side, it's got to be a right triangle. If the height, the shortest distance from here, possibly to get down to the line, is H, and A is shorter than that, no triangle. And that's going to be your favorite one because then you're done with the work. There's no triangle exists. For the other 3, A has to be bigger than H. So it can't go straight down. If it went straight down, it would go below that bottom line of the triangle. So we've got to angle it to the left or the right to make it fit. The trick, though, is if A is also shorter than B. So if the side that I know is shorter than the 9 in this case, then there's enough room to swing it to the left or the right to make either acute or obtuse for this angle out on the far right. So if A is bigger than H, but smaller than that adjacent side we were given, then we have to solve it for 2 triangles. That is our ambiguous case. But if A is bigger than H, so it's long enough to come down and make a triangle, we don't have that gap, but it's bigger than that adjacent side. That means we can't bend it down in here and have a bigger side than 9 going that way. It would have to come way out and make the zigzag. That makes no sense. So we only have that acute angle way out on the right-hand side. And as you do these, you're going to get more familiar and more comfortable with it. Right now, I know everybody's copying all of these things down, and you're going to be looking at them as you do your first few problems. But after you've done several of them, it's going to sink in, and you're just going to know what you're looking for, and you won't have to go back to the notes each time. Let me go ahead and go on to the examples for today. I'll put this slide back up at the end for anybody that did not quite finish writing this down. So first example, triangle has a 40-degree angle. So I'm going to draw something up here that's kind of sort of looking like it's 40 degrees, and I have no idea how long I'm supposed to draw that bottom side. I know that a side adjacent has length 9, and I always like to put that adjacent one on the top. You could put it either the top or the bottom. Those are both adjacent for the 40, but I like to put it on the top and keep all of my pictures consistent. I know the side opposite that 40 degrees is 4, and so all I'm going to do is write the 4 down for right now, because right now I don't know, should I draw it straight down at a right angle, or should I make it angle out so I have an acute angle, or in so I have an obtuse angle? I'll draw it later when I know which way to make it go. First thing that we had to do with those rules that you just wrote down was to find h, and our formula for h is that it has to be the adjacent side 9 times the sine of that angle that it's adjacent to. So this is where I need you guys to punch that in on your calculator and let me know what we're getting. And I'll hear from at least a couple of you to make sure we haven't had calculator entry errors along the way. Sophia, you have it already?
5.75.
Anybody else? 5.785? So I'm seeing some thumbs up, heads nodding. So 5.785 is our h. That's the shortest distance from that top where the 9 ends down to the other side. So then the second thing that we had to do was to compare that opposite side, little a, and h. So we're comparing 4 and 5.785, and 4 is shorter. The shortest distance to close it and make it a triangle has to be 5.785, and we only have 4, so it is too short. So that means my picture would look like this. And then that means that no triangle exists. And as I said, these are the ones that you guys will like, because then you're done. So you guys know me well enough, and you know how Saxon works. What do you think I'm doing for our one other example today? Just give me your prediction. We're going to do the ambiguous one, the one where we have 2 ways that it can work out, and we have to go through everything. Now, when you're doing them in the book, you won't necessarily know what's coming next. So draw it and find the missing parts. They tell us 1 angle and 2 sides. That means we have to find both of the other angles and the one other side, and draw the triangle that goes with that. Or if it's ambiguous, like we're predicting, we need to do 2 sets of those kinds of answers. So first thing I'm going to do is to start kind of trying to draw it. And I'm going to draw something where it looks like I've got about 32 degrees here. And I have no idea how long I'm supposed to draw that. And that is angle A, that is 32 degrees. I want to stress and remind you guys, upper and lower case of the same letter means they are an opposite pair. They could have said A is 32, and then B is 8, and then A is 6, but you'd know little a and big A must be across from each other. So across from the big A must be the little a, which is 6. Then they tell us another side that can be either of the other 2, but as I said, I like to put that on the top one of those 2. I like to draw the one I know up there, so that's little side B, which means whichever way I end up needing to draw that, that's going to have to be angle B down there. And then that means I can have an angle C up here at the top and a side little c down there along the bottom. First thing I have to do is to find h, and h needs to be that adjacent side 8 times the sine of the 32 degrees. And again, help me out with the calculator work here. What are we getting for 8 sine 32 degrees? I do want everybody enter all of the steps on here. Even if somebody says it out loud before you've quite finished, I want everybody to keep up with the steps and the things that we're going to be saving and all of that. Jet, what do you have for H?
4.239.
Anybody else? 4.239? Okay, lots of hands up, so that must be correct. Then we are going to compare A to H. What do you notice? Haley. So what does that mean? If the shortest way to go from up here at the top down to the bottom is 4, and we have 6. Is ours long enough to make a triangle? So yes, a triangle exists. Okay, then they're not equal, so we know it's not a right triangle. So then we have to decide, can we only bend it way out to the right where we have an acute angle way out over there, or do we have the choice of bending it out or bending it in where we'd have an obtuse angle? For that, we need to compare. So for this one, we had A was bigger than H, and we also need to compare it to the 8. And in this case, the 6 is smaller than the 8, or the A is less than the B if you want to do the letters, which means it's short enough to bend it both ways and get triangles. So yes, it is ambiguous as you predicted. I want you to do first, because it's easier on your calculators, and you'll see why as we go through that, do it first where B is acute, which means I am first going to angle that 6 so that it comes out here to make this be an acute angle. Because it's going to be the ambiguous case, I'm going to get 2 sets of answers, so I'm going to use subscripts to tell them apart. This is going to be angle B1 and angle C1 and little side C1. The others were all given to begin with, so I don't need subscripts for them. We know the 32 and the 6. They are across from each other. They are an opposite pair. Our rule is if we have an opposite pair, we start off by using law of sines. So we're going to take 6 over the sine of 32 degrees is 8 over the sine of that acute angle B, which I'm calling B1. So let's do our cross product, and we have 8 times the sine of 32 degrees is 6 times the sine of B, so divide both of those by 6, and that's the sine of B1. So that means B1 is the inverse sine of 8 sine 32 degrees over 6. That's what I want to see in your work. Go all the way to there before you punch it on your calculator. Don't do this time-wasting nonsense of sine 32 equals, and then store that, and then times 8, and store that, and then divide it by 6, and store that, and then take the sine inverse of what you stored. Enter that all at once, just exactly like that. Saves time. That's how you have enough time on the tests. So, who has that one for me now? Elena, you have it yet, or are you still working? Anybody else? 44.956? So, our acute value for B is 44.956 degrees. And now I want you to store that just as B. We don't store it with a B and a 1, but just the B is fine. And I'm going to circle that because that is part of my answers. So now let's look at what we know. We know 32 degrees and we know B1, and we're supposed to get the other angle and the other side. Todd, which do you want to do next? The other side? How are you going to get the other side at this point? I don't have the opposite angle yet. I had the 8 and I had the B. And how are you going to find that other angle? So, use what to get the other angle? No, because I don't have the opposite pair for it. I've got 2 angles. How am I going to get the third angle? Triangle sum. So, what you are going to enter on your calculators, now that you've stored that B1, you're going to enter 180 minus the 32 and minus that B that you stored. And who's gotten that already for us? Erica, you have it already?
Yeah, I got 103.044.
Thumbs up, thumbs down, 103.044. So 103.044, and that is our other angle, so uppercase C1. Circle that because that's one of the things that I needed to find. And now I want you to store that as C. now, Cal, for that other side, now we're going to use law of sines to get our other side. We're going to be able to say that that little C1 over the sine of C1, which is a stored value now, and then I'm going to go back to the 6 over the sine of 32. That was stored. And so then if I do my cross product, I have 6 times the sine of that angle C1 is equal to sine 32 times side C1. So divide both sides by the number sine 32 degrees, and that will be my missing side. Enter that all at once. Do your control divided by to get your fraction. This C1 was stored, so you're just going to do 6 sine C. Max, what you come up with?
11.030.
Thumbs up, thumbs down, 11.030. I'm seeing a lot of agreement here. And we don't know any units for that. So now I've found all of the missing things for case 1, where I angled that side out, so my first angle that I needed to find was acute. Now I need to slant that line that's 6 long the other way. So this is going to be my case 2 now. I did where B was acute. Now I'm going to do where B is obtuse. And I'm going to have to draw a new picture for this because it's going to change. I'm going to keep my 32 and my 8. And then instead of this 6 angling out to the right, I need to angle it into the left. But that side is still going to be 6 long. This was still big A and little a. This was still little b. So this is big B, but now it certainly looks obtuse in my picture. And I'm going to need to find this C up here and this little side C. And I'm going to put subscript 2 on all of those. And now, don't go ahead, because I'm going to show you the shortcuts to save you time with the calculators. From those word problems that we've already done with the cables attached to the tower, we know that if we got an acute angle and we really wanted the obtuse, what we need to do is to say our obtuse one is 180 minus our acute one, which we stored. So all you do right now is 180 minus B. And who has that? Gavin, you got that already? 135.044, others agree? And now I want you to store that as B. It will replace the B that you already had. The calculator will forget all about the acute one, and the only thing it knows now is that B is obtuse. Okay, now we're going to get our third angle with triangle sum again. And you could, if you wanted to, but don't do this right now, you could type in 180 minus 32 minus your stored B, which is now B2. But faster and more efficient, scroll up until 180 minus 32 minus B is highlighted, and hit enter. Because the calculator's forgotten the old B, now it's just going to use that formula with the new B in there. And Sophia L., what do you get for the new C?
12.956.
Anybody else? 12.956 degrees? And go ahead and store that as C. And let's look at our picture so far and see if this makes sense on our angles. When it was acute out here for our angle B was about 45 degrees. Up at the top, we had 103 degrees. When instead we bent that side that was 6 long inward. Does it make sense that we now have a much smaller angle up here at C? Okay, now let's get our missing side. And if you really wanted to, you could go through these same steps again and say that little side C2 is, and type in, take 6 times the sine of your stored C, which is now C2, as long as you remember to store that just now, over the sine of 32. Or you could simply scroll back up so that 6 sine C over sine 32 is highlighted and hit enter. And what do you get for that new little side down there at the bottom? So what did you come up with, Joe?
2.538.
Anybody else 2.538? And does that make sense when we look at our triangles? It was 11, and now it's 2.5. It was 11 when we angled it out to the right. If we angle it inward, does it make sense that that bottom side is a whole lot shorter now? So any questions on the work with that ambiguous case? One of the things I'm asking you to do is the subscripts to tell them apart. The other thing that I am going to ask of you to help us out is to please be neat when you do your work. For each of these problems, there's a lot of work, and there's one problem set box. And so you're going to have to start off, and you're going to have to find H, and you've got a little bit of work to do to find that. You really need to circle that, I suppose. Let me undo that, it's not so. But you're going to do a little bit of work to find H, and then you're doing your comparing, and maybe even comparing with the other side that you know. And then if it's ambiguous, you're going to start in, you're going to do your acute one first. So you're going to be doing some work here, and you're going to get what that acute angle is, and then you're going to use triangle sum, and you're going to get what that other angle is, and then maybe you finish filling up that column now, and maybe you're over here on the right-hand side of your box, and you're doing law of cosines again, and then you get little side C. So it took you quite a bit of space, most of the box, to get case 1. Case 2 is shorter, especially with those calculator shortcuts I just showed you. So then maybe you start in, and now you're doing your obtuse case, and so you've got what that angle is, and then what your other angle is, and then what that side is, and really all you have to do is write those down because you can just copy what you already had on the calculator. So maybe it would help to draw a line, something like that, to separate the acute and the obtuse cases to make it easier for somebody to read. So think about it as you're doing these to please, please, please make your work easier for me to read.